So the really cool use of this idea called a matrix is we can use it to model a system of equations and then use technology to solve the system for us. So this matrix is actually representing a system of equations. The way to read it is these are coefficients. So we generally go x, y, z, and then this is kind of the number after the equal sign. And sometimes we have a little line to kind of separate those. So this system works by taking your coefficients. So these are all your x's. These are all your y's. And then the last one here is your z's. So for instance, if I was writing this as a system, I would write the first row as 2x minus 1y plus 4z is equal to -3. So notice you're going left to right, and the numbers are only corresponding to the coefficients, right? The 2, the -1, and the 4. And then that last number is the number on the other side of the equals. So 1x minus 2y minus 10z is equal to -6. Try and do the last one on your own. Pause the video, try it out, and unpause when you think you got it. 3x plus 0y plus 4z is equal to 7. Notice you don't have to write that part there. You can just write it as 3x plus 4z. You may prefer just for cohesiveness to write them all, but you don't have to write that 0y. So all a matrix is doing is it's taking those coefficients. It's saying, okay, I know the numbers in front. Because think about it this way, when we're working with systems and trying to do elimination and substitution, the biggest thing we're focusing on is the coefficients. So this matrix is taking this information and it's putting it in a more simplified way, and then we're going to use technology to figure out what x, y, and z are. So this is a matrix, right? Coefficients are over here, right? So on this side. So maybe make a note about the coefficients. Sometimes you'll see the line used to separate the coefficients from the numbers on the other side of the equal sign. Not always. The next thing we're going to talk about is the dimensions or the size of a matrix. So I'm going to draw a matrix here, and I'm just going to put numbers like 1, 2, 3, 4, maybe 5, 6. Like I'm just kind of making some random numbers. So the way that we describe the size is we talk about the rows and the columns. And we call it, typically it's n by m. So basically it's rows by columns. So rows by columns. So for the matrix below, rows are side to side. There are 2 rows. And then the number of columns, if I do that vertically, right? 1, 2, 3. I like to think about columns, think about like Greek architecture, the columns of a building. So rows by columns, and you always say rows first, columns second. It's just kind of the agreed upon way, right? We have to kind of have a method or an order that everyone follows just for consistency. So that's how you read it, and that's mainly going to be useful in our calculator, in telling our calculator how big a matrix is that we want to plug in to find our x, our y, and our z. So this next idea is called reduced row echelon form, and it's kind of like a big mouthful. The acronym is RREF. And what reduced row echelon form means is, remember, we've got coefficients for x, coefficients for y. So I'll kind of put this here like x, y, z, and then your number, right? So the first one is corresponding to a system 1x minus 3y plus 5z is equal to -2, right? That's the first equation in that top one in A, and so on. And then you have something like 1y minus 4z is equal to 3. And then the last one, no x, no y, 1z is equal to 10. So this one's kind of nice because you can kind of say, okay, I know what z or 1z is. I can plug that in here to get y, and then I can plug that in here to figure out x. So this one's really nice in that you can figure out the values, right? If I look at the other ones, I'm going to talk about this bottom one. So this bottom one, if you read out the statements, this one has 4, so it's kind of a little bit cumbersome. So let's say x, y, z, and normally I only use 3, so I'm just going to call the last one maybe w is our 4th variable. So this one, if you read it, you've got kind of going left to right, 1x, no y, no z, no w is equal to 2/3. So basically that's telling me x is equal to 2/3, right? For the bottom one, no x, 1y, no z, no w equals negative 1/4. That's telling me that y is equal to negative 1/4. And if you keep going, you'll find that z is equal to 6/7. And then it looks like we don't have anything else. That bottom one has no digits. So z is equal to 6/7. So what that means is that this matrix is basically telling us x equals y equals z equals. And so this is what your calculator will actually give to you when it wants to give you what the answer to a system of equations is. So your calculator will give you this as an answer, and you'll have to know how to read it, knowing that the yellow line means that x is 2/3 and so on. So this is what's called reduced row echelon form. So this guy here is in reduced row echelon form. Basically what that means is it gives you all variable values. And you don't have to do any extra work to get there, right? You can read them left to right. So that is in reduced row echelon form. We saw that the first one was not. The first one you had to do some work, right? That was the one I just erased. I'll put that back for a second. Remember that first one, it gave you z, but you had to then use z to figure out y and then use that to figure out x. So because that one has work involved, that's not in reduced row echelon form, right? So pause the video and try and figure out which other ones also tell you the values of x, y, and z, similar to how E told you x was 2/3, y was negative 1/4, and z was equal to 6/7. So try that out and unpause when you're ready to check. Okay, so if you're unpausing, let's circle the other ones that are reduced row echelon form. This certainly is. We have x is equal to negative 2/4, y is equal to 0.8, and z is equal to 5/6. Looking at the other ones, this one here is giving you 2 separate equations involving our second variable. So they're both telling you about y, but they're not telling you anything about x. This bottom one also has some work that needs to be done, right? We're kind of looking for all ones surrounded by zeros. You're kind of seeing that pattern there. Ones surrounded by zeros. I'm not seeing that here. I'm not seeing that here. That's going to involve some work. So this is how your calculator will tell you an answer to a system, right? It will give it to you in this form. So that's why we need to know how to read it. So what we're going to move to now is some practice in how to use our calculator to solve a system. I'm going to go back to the very beginning. Here are the 2 problems that you guys solved with a system of equations. So we're going to look at how to use our calculator to solve these systems. The first thing I'd like you to do is pause the video and write these both as augmented matrices with all the values filled in. Okay, so here are our 2 systems written as matrices. You should kind of start being able to kind of see that matching with the coefficients as we look at the 2 pairs. If I want to talk about the size of these matrices, double check yourself. What is the size, right? The rows by columns, right? Rows are side to side. There's 1, 2 rows, and then there's 1, 2, 3 vertical columns. So we would call this a 2 by 3 matrix. That's the size. So now we're going to put this in our calculator. Okay, so the place you go, notice if you click the yellow button and then this button here, you see the matrix. So I need to click second, and then I get matrix. Now I want to use matrix A. I'm only going to be focusing on the top one first. I'm going to go over to edit, and I'm going to edit matrix A and put my numbers. Oops. Sorry about that. So right here, this is the size of the matrix. Generally, a 2-variable system is going to be 2 by 3, just based on the size. If you wanted to change it, you could type in new numbers, but this is actually the right size. So I'm going to press enter, enter, and I'm going to type this, 119. So 119. Yours might not have any numbers if you've never used it. 2, -3. I just type it and press enter, and then a -2. Okay, and then I've typed it in. I'm going to now double check, kind of go and left to right and verify. So now that I've typed it in, I'm going to do second mode to quit. Notice quit's above there. And I'm going to do my matrix button one more time. So second, x to the -1 has that matrix. Now I'm going to, instead of going to edit, I'm going to go to the middle, which is the math button. And I'm going to scroll all the way down to look for reduced row echelon form. You want the bottom one. You don't want the one with 1 R, you want the 2. I'm going to press that enter, and then I want it to find that for this specific matrix. I'm going to do second matrix. Because I could have a bunch of matrices, I need to tell it to look at matrix A. So I have it over matrix A. I'm going to press enter, and then enter one more time. And what the calculator is doing is it's giving me the reduced row echelon form of the particular matrix I put. So 1, 5, 1, 4. Okay, so I'm going to put that here, and I'll have that up here. Notice they don't have that little line that we normally put to separate the numbers from the coefficients. That's fine. If I rewrote this, remember it goes x, y number. 1x plus no y equals 5. 0x plus 1y equals 4. Basically what that's telling us is x is equal to 5 and y is equal to 4, right? You don't have to write it out formally like I did before. This is perfect. So that is our answer to our system, and we didn't have to do any algebra. We used our calculator as a shortcut, right? So we can really appreciate how nice this is to have this as a tool now that we know how much work goes into solving the system. So what I'd like you to do is try out the second system of equations, right? We have it written down here. Go ahead and go through the same motions in your calculator. You can replace matrix A with this one or put it in matrix B if you want. So go ahead and try it out on your own. Unpause the video when you're ready to check. Okay, so I've just done that with my calculator, and I put it in matrix B just to keep it separate, and I got this. So I rewrote it in a matrix, and then I figured out that x and y were both 1. So hopefully that helps, having done it a couple times. It takes a little bit of practice to get used to it. So I've got a couple of practice problems for you to do just to make sure you're feeling okay about this calculator command. So here are 3 practice problems. I'll call them practice A, B, and C. So go ahead and rewrite these in augmented matrices, and then unpause when you're ready to double check just rewriting them, not necessarily solving. Okay, so here are the matrices. Notice for like a coefficient of 1 or -1, right? You don't have to write it in. I just wrote it in for remembering. Remember, it's x coefficient, y coefficient, number on the other side of the equal sign. Now, try out that calculator maneuver and go ahead and practice doing the reduced row echelon form command. Make sure that you double check that you're calling for the right matrix. Okay, so I've done the reduced row echelon form on my calculator for each of those. The first one I got x is 2 and y equals -3, a concrete point of intersection for my 2 equations. The second one, B, I got 0 equals 1. You can see the highlight there in pink. So what that means is that there's no solution, kind of like we're used to seeing an untrue statement. So now you can kind of make that connection with what it looks like in a matrix. Similarly, getting 0 equals 0 means infinite solutions. That means the first line is representing the line, the equation of the line, for which anything on that line is technically a solution because they overlap. Okay, so that's it for today. Thanks for watching.